Now let's talk about the other scenario when analyzing an analysis of variance test. The other scenario is when the p-value is less than the preset p-value and it is statistically significant. So when I look at the SPSS data, let's look at the still using the weight as a dependent variable, and this time we change the independent variable to grade level. I'm using grade level as the independent variable because this is a one-way ANOVA situation. Weight is a continuous variable and grade level is a categorical variable with 4 categories: grade 10, grade 11, grade 12, and grade 9. And the hypothesis would be there is a significant difference on average weight among students in 4 different grade levels. Or we can make it directional. We can say 12th graders' weight is higher than the other 3 groups. So if we go to analyze, compare mean, one-way ANOVA, this time we put a student weight as a dependent variable and grade level as the independent variable, and we'll go to the option again to look at descriptive and put descriptive statistics here and say continue and then OK. So when we look at the analysis here, we will be able to see there is a difference. We can observe some differences on mean weight among the 4 different grade levels, and we can see that 10th graders' average weight is higher than the other 3. 10th graders' average weight is 275 pounds, while the others are a little bit less. You know, the 9th grade is 159, and so on and so forth. But the question is, by observing this, we know there is a difference, but are these differences large enough to be statistically significant? How confident we are? What is the error rate we are willing to risk when we claim that there is a significant difference? And this difference is going to be repeatable below the error weight we estimated. So when we go to the ANOVA analysis here, when you look at the ANOVA, you'll be able to see, I said ANOVA test is an F test. It's a ratio of the between group differences by the within group differences. So the between group differences is here is 28508.692. The within group differences is 2335. So the ratio, F ratio, this time is fairly large, which means the differences, well, considering the between two group differences, between group means between 9th, 10th, 11th grade and 12th grade, between the different groups differences, in comparison with the within group there is difference. Within 9th graders there is a difference between each one of the 9th graders. Within group differences, that's within group differences. So the ratio of between group differences and within group differences is large. That indicates the differences is truly large. And if this F ratio is large, that means the p-value, the probability of type 1 error is going to be small. So in this case, the p-value, the probability of type 1 error is 0.0000. Well, we can say the p-value is less than 0.001. We don't usually say p-value equals to 0.001. So in this case, the p-value is, the type 1 error is less than the preset probability of type 1 error. We set it at the 0.05 level. So this error is less than 0.05. So which means the error is less than the preset value. So we can say there is a significant difference on average weight among the 4 grade level groups. In another word, the differences we observed here is very confident, and there's only 1 out of 1,000 times error involved in these observed mean differences. So if this is the case, we have to do further analysis to identify which group is significantly different from which group. There are 4 different groups here in comparison, but the 4 groups when we compare, we can compare 9th graders with 10th graders, 9th graders with 11th graders, 9th graders with 12th graders. So that's 4 groups already here. And that's 3, 9th with 10, 9th with 11, 9th with, that's 3 groups here already. And then we can go to 10th graders. 10th graders can compare with 11th graders. 10th graders can compare with the 12th graders. So then 3 plus 2, that's 5 groups already. And plus 11th graders will also be able to compare with the 12. So 3 plus 2 is 5. 5 plus 1 is 6. So there will be 6 multiple group comparisons for our post-hoc to determine exactly how different each group is different, whether the difference is statistically significant. So then we go to analyze, compare mean, one-way ANOVA. There's one thing we did not check, which is the post-hoc. So if we click on post-hoc here, these are different types of post-hoc methods, test methods. So I checked Bonferroni. You can pretty much check any one of them. So I checked Bonferroni just because it's the most often used post-hoc analysis test method. So I use Bonferroni multiple group comparison test to test the specific group mean differences and see if it's significant. And I wanted to set up my p-value, so the significant level, which means the probability of type 1 error or significance level at the 0.05 level. And I'll say continue. Okay. So in this case, you will get 2 tables like this we did before, but you will get an extra table, which is a post-hoc table. And the p-value is set at the 0.05 level. You will be able to see there is a star mark here indicating that this group mean is significant, different. Is statistically significant. So by looking at this table is a little bit redundant because we compare 9th graders with 10th graders, and here again it compares 10th graders with 9th graders. But we know 10th graders and 9th graders and 9th graders with 10th graders are the same, except the direction. If we compare 9th with 10th, it's a negative. If we compare 10th with 9th, it's a positive. But the number is still exact the same. It's just the difference direction is different. One is positive, the other is negative. So we know we have 6 groups comparisons. So 9th graders with 10th graders, it is statistically significant because the p-value is less than 0.001, less than the preset value of 0.05. So there is a significant difference on average mean between 9th graders and 10th graders. And 10th graders is significantly higher than the 9th graders. If we compare 9th graders with 11th graders, the significant difference, the p-value is 1.00. The type 1 error is larger than the preset p-value of 0.05. So in this case, this is not significant. In another word, even though there is a 13-point difference between 9th graders and 10th graders, 11th graders, but that 13 points difference is not going to be repeatable. The error is too large. And 9th graders, comparing 9th graders with 12th graders, the p-value is 0.263. So the p-value is also larger than the preset value of 0.05. The larger error indicates there's no significant difference, even though there is a 24 pounds difference between 9th graders and 12th graders, but the difference is not going to be repeatable. It contains too much error to be confidently claimed that there is a true difference between the 2 groups. And then for 10th graders, we already compared 10th with 9th graders. We'll just go by 10th graders with 11th graders. So 10th grade and 11th grade comparison, 10th graders way much higher, and the p-value is 0.000. That means there is a significant difference on average weight between 10th graders and 11th graders. And there's also a significant difference between on average weight between 10th graders and 12th graders. So 10th graders and 11th graders, 10th grade and 12th graders are all significantly different from each other. And from the 11th grade, we need to compare 11th grade with 12th grade. And 11th grade and 12th grade, the p-value is large, is too large to be significant, because this is larger than 0.05. This is 0.099. So in this case, we can say there is no significant difference among 10th graders and 12th graders on average weight. So from the post-hoc analysis, we only have 3 group differences, which are all here. It's that the 10th graders are different from 9th graders, 11th graders, and 12th graders. But it seems there is no other differences among the other groups. So in this case, we need to calculate the effect sizes to determine exactly what is the ranking comparison of the 2 different groups when the p-value is significant in post-hoc multiple group comparison analysis. So in the next demo, I'll show you how to calculate effect size and how to interpret effect sizes.